On July 28, 2026, a magnitude 7.1 earthquake shook Kumamoto Prefecture. It was a shallow event, occurring just 10 kilometers beneath the surface, and registered a maximum intensity of 7 on the JMA scale. In Uki City, peak ground accelerations reached 1.7 G, causing the collapse of industrial structures and triggering utility fires. The sheer force of the movement sheared the supports of modern commercial buildings, including the Aeon Mall in Kashima. Shaking of this intensity causes immediate, catastrophic structural failure across residential and commercial sectors. Seismologists categorize this as a pre-megathrust seismicity shift. This inland rupture along the Hinagu Fault indicates that regional tectonic strain has reached critical levels across southwestern Japan. Following a magnitude 7 event in this region, the Japan Meteorological Agency immediately activates a high-level evaluation protocol. Experts must determine if the inland earthquake transferred enough stress onto the Nankai Trough boundary to trigger a Nankai Trough Extra Information Advisory. This inland rupture is a direct byproduct of the same tectonic engine driving the offshore trench, signaling that regional strain across southwestern Japan is now critically high. Southwestern Japan's geology is defined by the Philippine Sea Plate sliding under the Eurasian Plate at 4 to 5 centimeters annually. This massive tectonic engine drives both the offshore trench and Kyushu's inland faults. As plates lock, immense physical stress radiates into the islands. Major subduction zones often experience a rise in inland crustal earthquake activity in the decades leading up to a full megathrust rupture. The rupture in Kumamoto was a release of localized stress acting within a regional system that is currently under extreme compression. The inland fault acted as a localized pressure relief valve, indicating that the broader tectonic system is nearing its physical breaking point. The primary threat lies offshore in the Nankai Trough, a 700-kilometer undersea trench stretching from Suruga Bay to Kyushu. This is a locked boundary where tectonic tension has been building for decades. Historical data shows that megathrust quakes at this boundary recur every 90 to 150 years. Strain has been building continuously since the last major events in 1944 and 1946. Over 80 years have passed since that tension was released. Japan's Earthquake Research Committee estimates an 80% probability of a magnitude 8.0 to 9.1 megathrust quake occurring within the next 30 years. Because the plates have been locked for 8 decades, the physical capacity of the fault to absorb further stress is nearly exhausted. The inland quake in Kumamoto gave residents 0 to 5 seconds of warning before extreme localized shaking began. A Nankai megathrust will provide up to 60 seconds of warning, but the JMA 7 intensity shaking will cover vast regions of Honshu and Shikoku simultaneously. Inland quakes primarily threaten buildings at the epicenter with high peak ground acceleration. Megathrust quakes introduce long-period ground motion that can damage high-rises and cause liquefaction in coastal cities. The most critical difference is the tsunami. A Nankai rupture will generate near-field waves exceeding 30 meters, reaching coastal communities like Kochi and Wakayama in as little as 5 to 10 minutes. These two disaster types require entirely different preparation strategies, from structural reinforcement to mass evacuation timing. For rescue teams, Kumamoto required heavy lifting and urban search and rescue, focused on structural collapses. A Nankai event will demand wide-area water rescues, the management of mass evacuation protocols, and the deployment of relief supplies across half the country. Yesterday's earthquake in Kumamoto is a clear signal of the tension building offshore. Understanding the link between these inland faults and the Nankai Trough is essential for surviving the moment that pressure finally breaks.